The differential housing is the main casing that holds the gears transferring power from a vehicle's driveshaft to its wheels. It must be extremely strong and precisely made to handle massive torque, heat, and vibration. The process begins with high-grade iron or aluminum alloys, depending on vehicle type and weight requirements. Raw materials such as pig iron, scrap steel, and ferroalloys are carefully weighed and loaded into the furnace. Factories typically use medium-frequency induction furnaces to melt the metal efficiently. The temperature inside the furnace reaches 1400 to 1600 degrees Celsius, turning solid metal into glowing molten liquid. Skilled operators continuously monitor the temperature and chemical composition using spectrometers. Any impurities rise to the surface as slag, which is skimmed off to ensure metal purity. Meanwhile, molds for the differential housing are prepared using sand casting or permanent mold casting techniques. Sand molds are made from silica sand mixed with resin binders, compacted tightly around a model of the housing. The core, which creates the hollow space inside the housing, is made from special heat-resistant sand. Precision in core placement is crucial because even a few millimeters error can affect gear alignment. Once ready, molten metal is poured into the mold through a system of sprues and runners. The pouring must be steady and controlled to avoid turbulence and air bubbles that could cause defects. After pouring, the mold is left to cool and solidify naturally for several minutes or hours, depending on size. When the metal cools, it shrinks slightly, locking in its final dense and strong shape. The solidified casting is then removed from the sand mold, a process called shakeout. The used sand is recycled and reconditioned for the next molding cycle. The rough cast housing is transported to the cleaning and shot blasting area. Shot blasting uses high-speed steel pellets to remove sand, scale, and surface impurities. Workers then grind off excess material, like sprues and flash, for a smooth surface finish. Each housing undergoes X-ray or ultrasonic testing to detect internal voids or cracks. The next step is heat treatment, where the casting is reheated and cooled in controlled conditions to improve strength and toughness. After heat treatment, the housing goes through CNC machining to achieve precise dimensions. Critical surfaces, like bearing seats and bolt holes, are machined to micron-level accuracy. Coordinate measuring machines, CMM, check all geometric tolerances against the 3D model. Some differential housings are impregnated with resin to seal microscopic porosity and improve durability. The surface is then cleaned and coated with anti-corrosion or paint finishes for protection. The inner cavity is deburred and polished to ensure smooth oil flow inside the differential.